CIT 1123, Packet Tracer Instructional Video 2311. In this video we're going to go through the DR and the BDR designated router, backup designated router. Idea is this: when we're on a multi-access broadcast network, aka Ethernet, the standard point-to-point update mechanism for OSPF is a little bit of overkill. So example here, device A has a change that it wants to send to device B and C. No problem, A will send the change to B and C and they will update their databases. And then here's where things go wrong. B will update C and C will update B because they're both neighbors as well, and they don't realize that the other one already has the change. So what we're going to do is this, is we're going to elect a router as the designated router. And then any device in the system that has a change to be made will receive those updates, and then that router, the designated router, will then in turn pass those updates back to the other routers in the system, and that will remove the superfluous extra updates that would happen when we have a lot of routers connected to one Ethernet system. So that's the whole idea of what we're going to do here. The lab, I've gone through this one several times, doesn't always do exactly what it's supposed to do. So we'll say what it's supposed to do. Hopefully it'll work close enough to being right. At the very least, we'll be able to score all the points. So let's go ahead and get into it a little bit. Router A, first thing we're going to do is look at router A's neighbors. So I'm going to do that with the show IP OSPF neighbor command. So let's go ahead and get into router A here. Show IP OSPF neighbors, and we can see that A has two neighbors, and those neighbors are identified by their loopback addresses that have been placed on router B and router C. And we can see that the loopback address of router C, 192.168.31.33, is the designated router because it has a higher router ID than device B. Device B becomes the backup designated router because it has a higher IP address than the loopback address on router A. So when all three of these routers powered up, they had an election. C had the highest router ID, B had the second highest router ID, A had the third highest router ID. So we identify each one of the process, or each one of the positions that you could be in with the designated or backup designated or druther state. So A is a druther, B is a BDR, and C is a DR. Okay, easy enough. All right, now what we're going to do is we're going to take the designated router offline, and we're going to watch and see what happens. So when we get down here to step 3, it says turn on IP-OSPF adjacency debugging. So we're going to set debugging on, and if you haven't done debugging before, the debug command is a command where it'll show you extra information about a particular event. In this case, the event that we want to see more information on is OSPF neighbor adjacencies. Easy enough. Great. Now, what we're going to do in step 4 is we're going to turn off this interface, effectively taking the designated router out of the system. So let's go to router C here, and let's go to that interface. G0/0, I think, and we're going to do we're just going to do a shutdown, not a no shut. We're going to do a shutdown, and that's going to take the designated router out. Now, taking the designated router out of the system is going to change who the designated router is going to be. So what will happen here is B will become the designated router, and A will become the backup designated router, and those updates will show up on A's debugging in just a second here. I'm going to scroll this down to show you where we are right now. So what we did here is we just did that shutdown here in step 4, and we're waiting for A to figure out, oh, it just happened, A to figure out that C is no longer on the network, and a new election has just happened. 3122 B has now become the designated router, and 3111 is now the new backup designated router. So that's our new process there. That's pretty cool. And if we just did another show just for fun, let's do another show IP OSPF neighbor, we can see that we now only have one neighbor, and that neighbor is a designated router. Okay. All right, so that's pretty good. So that was shut down here. We waited. We just did this. So we just did this step here. We're going to go ahead and re-enable that link and see what happens. We go ahead and re-add it. What should happen, oh boy, this is where it always doesn't always do what it's supposed to do. But what should happen is this. We'll do a no shut on this interface. We're going to bring C back into the OSPF autonomous system, or area 0. And what should happen is B should remain the designated router, and A should remain the backup designated router, because these roles are already set. But it doesn't seem like Packet Tracer always does exactly what you think it's going to do. But as far as answering practice questions for the exams, you want to say that when the DR is removed, the backup designated router becomes the designated router, and another router becomes the backup designated. And then when the DR is reactivated, no change is made. And what we're going to see here is it may have, looks like it worked correctly this time. Man, I've tell you what, I've done this like so many times, and so many times it has it's not worked in Packet Tracer, and it's been incredibly frustrating. But it looks like we're okay this time. Let's just take a quick check. If we show neighbors now, and yes, okay, we're in great shape. This is what was supposed to happen. B is still the designated router, and C, even though it has a lower router ID or higher router ID, it does not retake the role as designated router. This is exactly what we were looking for. Fantastic. Your results may vary, and it does note in the lab, it says, hey, by the way, your results right here, this might not work right. So it is what it is. All right. Let's go to step 6, where we're going to disable the G00 on B and then wonder what's going to happen, right? So let's go ahead and do that. So if we minimize this one, let's go ahead and take a look at B. And we're on B. We're going to disable the link between B and the switch to cause the roles to change again. INTG0/0. And we'll do a shut on this guy. Now that was there we go again, that was our designated router. So what should happen? A should become the designated router, and C should become the backup designated router. Let's see what happens here. A, which router was selected, the DR, which was BDR. It should, well, I mean, there's only one choice for BDR. So let's see if this is finished, and it hasn't figured it out yet. It's going to take 1 second. I could speed it up, but I'm just going to go ahead and let it run. And there it goes. And the new election and the designated router does become A. So we've rotated the designated router in this scenario from C to B all the way over to A. Pretty cool. And they're going to say, okay, well, you can do show IP-OSPF neighbors again, and you can see that your only neighbor now is device C, and it is the backup designated router. And it fulfills that role because, remember, the backup becomes the designated, even if another one comes in. So this is working exactly as it was supposed to. Another command we can use to check this out is show IP-OSPF interface, which we can now look at here, and it shows us here who the designated router is and who the backup designated router is. So that gets us through step 7. At this point, they're going to ask us to turn the debugging off, which is undebug all is the easiest way to do that. So we'll go ahead and turn off all the debugging, and we now have no more debugging on. And let's go down to part 2. Now in part 2, what we're going to do is we're going to change the priority value, which is supersedes the loopback address, as a value to identify the default router, who we want the default router to be. So In this case, what we want to do is we want to change the DR and the BDR to use the priority value, and we're going to make A a higher priority, B the secondary higher priority, C is going to have a priority of 1, which is the default, but we're going to set that anyway, because if we don't, we won't score the points, and then the lab will be incomplete. So let's go ahead and take a look at what they are asking us to do here. First of all, well, we'll turn B on in just a second. Let's go back to A, and let's change its priority. So we're going to go to config T, and then interface G 0/0. Oops. And we're going to use the command that they typed in there for us. So IPOSPF priority, and we're going to set this to 200. By default, it's 1. Higher priority takes precedence over lower priorities. So we've now changed the priority value, so router A should remain the designated router at this point. Let's go ahead and change that. And let's go back to B, and we can do a no shut on that interface. And we're on the interface already, so we'll just do IPOSPF priority. And this one we're going to set to 100, and that's done. And let's go to device C, and we'll do the same thing here. We're on the same interface already as well, IP OSPF priority, and we're going to change that one to 1, and we are set to go. So starting with A, if we want to go ahead and update all this, we can clear. One of the ways we can do this is to get the changes, get the changes to update in the system is to clear it. So we'll do clear. Let's get it from a straight line. Clear IP OSPF process. Yes. And we're going to clear it. We'll run it, and it says, okay, starting with A, clear the process. We can do B, and we could do C as well. Verify the elections were successful. And just take a quick look at that. So show IP OSPF neighbor, and sure enough, we're all good to go here. Device A is the designated router, B is the backup designated router, and C is the druther device that we've seen in the past. Okay, so that completes point-wise and theory-wise the lab 2.3.11. I'll see you in the next lab.